Hello, Algebra 1. These are your notes on how to multiply rational expressions. So before we do that, let's go ahead and show you a formula that defines multiplying rational expressions. To multiply, you essentially need to multiply your numerators and denominators. A rational is denominators, O-R-S. Essentially, rationals are fractions. So if I have 2/3 and I want to multiply it by 3/4, that's the same thing as 2 times 3, which is 6, and 3 times 4, which is 12. Now, once we get to that point, we know that that's the same thing as 6 times 1 over 6 times 2. The 6's can cancel out, and that reduces to 1/2. Mathematically and algebraically speaking, we say that's the same thing as taking a over b and multiplying it by c over d. You essentially multiply a and c and b and d and then simplify as necessary. Go ahead and copy that down, please, and then I have some problems for us to work on. Okay, here goes example number 1. Let's start off with just rational expressions that have monomials in them. So let's take x squared over 3x. I'm going to multiply that by 2x to the third over 4. Well, when you multiply those, you literally multiply the two numerators, and that gives us 2x to the 5th power, and then you multiply your two denominators, that gives you 12x. Now, we're not quite done here because we know we can definitely simplify. That's the same thing as 2x times x to the 4th over 2x times 6. I can cancel out a 2x on both my numerator and my denominator, and that gives me x to the 4th over 6. It's essentially just reducing a fraction. Here's another example for you. Example number 2. In example number 2, we have 3x plus 5. We now have a binomial over x minus 2. And over here we have x squared minus 4 over 5. Now, it's really tempting to go ahead and take these guys and use the distributive property. What I'm going to do instead of that is just to write them together. I have 3x plus 5 times x squared minus 4 over x minus 2 times 5, or 5 times x minus 2. We're not quite done here. I can take this x squared minus 4 and it can be factored some more. So let me move down here. I have 3x plus 5. Nothing else can be factored out of that. But x squared minus 4 can be reduced to x plus 2 times x minus 2. And on my denominator, I had 5 times x minus 2. Now you have that situation where you have an x minus 2 on the numerator and the denominator. You could then reduce that by canceling out those x minus 2's, and your final answer is 3x plus 5 times x plus 2 all over 5. So that's fully reduced. Go ahead and take a moment to copy that down, otherwise we're going to move on to example number 3. In example number 3, let's bring it back to a simpler fractional situation, such as 1/8 of 24. When you're multiplying that out, you need to remember 24 is the same thing as something over 1. You now have 2 numerators and 2 denominators. That gives you 24 over 8, which is the same thing as 8 times 3 over 8. And then your 8's cancel each other out, and you have 3. Take that same concept, but now throw in some polynomials, such as 3 over x plus 1 times 2x plus 2. Just like the previous example, you need to remember you need to take that guy and put it over 1. You now have 2 numerators and 2 denominators. That gives me 3 times 2, x plus 1. And over here I have 1 x plus 1 times 1. Cancel out my x plus 1 on my numerator and my denominator. It looks like this. 3 times 2 is 6. 1 times 1 is 1, so my answer here is just 6. My x's cancel out. Alright class, let's do one more example together. This is example number 5, and this will be the last one. Example number 5 has 7x over x squared plus 5x plus 4, and we want to take that and multiply by x plus 4. Just like the previous example, take that second binomial, put it over 1. You now have your numerator and your denominator. Factor out as much as possible. Right now the numerator is fully factored. Your denominator can be factored. You get x plus 1 times x plus 4. I could cancel out something from the numerator and something from the denominator, and that just gives me 7x over x plus 1, and that's your final answer. Alright class, these 5 examples will be collected tomorrow. Have a good evening.